Hello, this is Reading Rails and I'm Mike Verada-Stone, and today let's explore the core extension set of extensions in Active Support. So I think these are all essentially monkey patches for various classes, like you can see integer and hash. And I'm just going to dive into one and see where it takes me. So we'll start with hash. No real reason. So this is all the hash extensions, and it looks like they're all just in the hash directory. So I'm going to just open up that directory and start going from there. And I don't really know where would be a good place to start, so let's just do the first one. Compact. So this is exposing a compact and compact bang method. So it returns a hash with non-nil values. Okay, so that's similar to array.compact. So if we go in here into our IRB, I'm pretty sure that's a standard method. All right, and then so what this is saying is it's exposing a compact that will affect values that are nil. So let's just see what happens before we have that extension. So ABC nil XYZ 1, 2, 3 dot compact undefined. So this exposes that, and if I require just that, we should be able to then run that, and sure enough, just like the documentation says, gets rid of values, key value pairs that have the value as nil. So let's just see how it's implemented. So it's pretty simple. Select is going to just return everything where this is true. So underscore, I'm kind of familiar with that pattern. If it's the same as what I'm used to, it just means that the key is ignored, which we can see in the block that that's true, so that's nice usage there. And if the value is not nil, then we are going to go ahead and keep them, so those will be selected. So this will return a new hash, whereas compact exclamation point is going to replace the current hash. So it's going to reject anything in this hash that has a nil value. So that way, if we had our original hash example, we said h.compact. Now h has been modified. So cool. All right. Well, let's look at the next one. Conversions. Oh, bunch of stuff required in here. Returns a string containing an XML representation of its receiver. All right, so if we just say our hash.toXML, we'll get a string XML representing that that hash. A lot of documentation for that. Okay. toXML, that's got a lot of stuff. I'm just going to see what all is in this file here. So there's more XML. So it looks like this whole block here, exposing the hash, is just managing XML conversions. Whereas if we go down here, what's over here? Okay, so that looks like it's probably just some kind of helper for that XML conversion. Deep to H. Interesting. I'm not sure what that does. Deep to hash, maybe? Process hash. Whoa, that's a lot of code here. Now, does that become content or become content? Okay, so conversions is really just converting XML, it appears. XML mini. Well, this looks like this could be just a deep dive in its own, so I'm going to just see what other things we have. So let's just look at the next one. Deep merge. Okay. So deep merge is just one little method. So it makes me wonder, are all these Ruby files here just individual extensions to hash, or is it sometimes more than that? I'm not sure. All right, so let's look at deep merge. So returns a new hash with self and other hash merged recursively. So if we have H1 and they see H1 and H2 both have A, they both have B, and in the case of B, it's in turn a nested hash with different keys. So the result then is going to be merging that nested hash. Like with hash merge, in the standard library, a block can be provided to merge values. Okay. I did not know that you could do that in merge. That's pretty cool. So what is this block concept? So I think it's saying, okay, so key, this val, other val, this val plus other val. So it's exposing how to do the merge of that key, I presume. So what's different here? So we have A is unique in there, so it just gets inserted. B is a number, 200 and 250, just adds the two together. And then C, C1, so those get added together as well. Okay, so I suspect that in the case of the two hashes having different keys, that this block probably won't be called. But let's try that out and see if that's true. So I'm going to require my deep merge, and now I can say I can have H1 equals A is going to be a hash with B 1 2 3, and then H2 will have A and C 3 2 1. Sorry for that spacing. That I just realized I did that, and that probably bothered a few of you. Bothers me now that I look at it. Okay, so H1 dot deep merge H2. We'll pass in a block with a key. We'll call it V1 and V2, and we'll just say, I'm just going to do a puts just to see if this is actually called. So I'm here. Okay. If we run this, it's going to return nil for that key. That doesn't matter. And sure enough, that's not called. So if we change our H2 to instead conflict, and now we merge it, now we're called. And since puts returns nil, then we got nil for our B key. Okay. So that's pretty cool. All right, so let's see how it works. So in the case of returning a new one, it just dupes the hash and then does the deep merge. So it seems like that makes sense. I do wonder, is the dupe going to be a deep merge or a deep dupe? Let's just test that. I'm curious. It probably is based on the results. I don't think this would be like that if it weren't a deep dupe. So let's just have H equals a 1 2 3, and then H1 equals a H, and then H1 dot deep merge H2, and then we say H. Actually, I guess I should store this. And H is still unaffected, so HC equals 555. And merged was unaffected. But let's just check. My variables are starting to be a little confusing, but whatever. B123 and H2 equals AI. That worked out interestingly. Okay, so let's redefine merged. So we got our two hashes merged, and C equals, actually let's just use another one just to see if that would show up. 666 merged, and sure enough D is not included there. Cool. So the dupe is a deep dupe. And deep merge exclamation point is then called, which means it's just calling this down here. And this just goes through each pair. Current key, other value. This value equals self current key. Self current key equals if this value is a hash and other value is a hash, this value dot deep merge other value block. So if block was provided. Okay, so it's just recursively calling deep merge, which I guess that perfectly makes sense since it's recursively merging each hash. So otherwise, so if they're not both hashes, then it's gonna do the merge right here. So if block given and key current key, so I'm presuming this inspects to see whether or not this current key is a key in the hash, then call it with the current key and this value and other value. Okay, and just like the example I did in IRB, it's just going to take the result of that and use that for that key, since there was a common key in the two hashes. Otherwise, use other value. So if there is no key for that other key, then just use the one in the other hash. Pretty straightforward. Cool. Well, I think that just about wraps up this little dive into hash extension methods. We could definitely go further and explore some more of these modules. I bet you each one is very self-contained. It's kind of cool that each of these is very single-purposed in what they monkey patch on hash, and that means that if I only want one particular thing, I can pull it in explicitly by just requiring that. If I don't want to pull in all of active support. Now it was a little interesting to me that conversions is actually XML conversions. So I wonder why it's not named that. I wonder maybe if other conversions are intended to be in here eventually, or I don't know. So that's kind of an open question for me. But at any rate, please comment with whatever I missed in what we looked at. And if you have any suggestions for future episodes, please add those comments as well. And if you like what you saw, give it a like. And if you really like it, go ahead and subscribe. And thank you for your time.